Hello dear students, good morning. Today we are going to discuss a very important topic. Explain Newton's first law based on second law. That is the question. Already we discussed what is Newton's second law, isn't it? And we come to the mathematical formulation of Newton's second law, that is F is equal to ma, and unit of force is found to be Newton. Now sometimes you will be asked to write Newton's first law, not stating Newton's first law, but write Newton's first law based on Newton's second law. So from Newton's second law you have to derive Newton's first law. For such type of questions, firstly you have to write, we know according to Newton's second law we have the equation F is equal to m into a. Here a is equal to v minus u divided by t. Substituting this value of a in the equation f, we got f is equal to m into v minus u divided by t. We already know f is equal to ma, and for a we are substituting the value v minus u divided by t. Is it clear? Very easy. M into, instead of a we are substituting v minus u by t. We already know this value from where? From the first chapter, acceleration is equal to v minus u by t. Now m into v minus u by t, let us open the bracket. So it becomes mv minus mu divided by t. Now let me take this t to the other side. So it becomes f into t equal to mv minus mu. How it becomes f into t? As it is by t here, if you are taking to the other side of the equation, by t becomes into t, divided by t becomes multiplied into f. F into t equal to mv minus mu. Now let me rub this thing. So here, and we have to stop here. So here we have ft is equal to mv minus mu. Now we have to give, what was the condition of first law? Think, what is the first law of motion according to Newton's first law of motion? If no external force is acted on a body, the body continues to be in the state of rest or uniform motion. Or we can tell, the body continues to be in the state of rest or uniform motion unless an external force acts upon it. So if no external force act, f is equal to 0. If no external force act means f is 0. External force is equal to 0. If f equal to 0, what is the value of f into t? That is 0 into t. What is 0 into t? 0. So this side becomes 0. And here we have mv minus mu. M into v minus m into u. Let me take this mu to the other side. It is minus mu. If I take this mu to the other side, how it will become? It becomes plus mu, isn't it? So it is mu equal to mv. Now can we cancel this m? Yes. If we are writing, or if the m comes in both sides, we can cancel them. Or if you have any confusion in that, let us think like this, mu equal to mv, isn't it? Bring this m to the other side. It is m into v. So when it comes here, it becomes divided by m. Now m by m equal to 1. So we get u equal to v. Either you can do this way, or you can just cancel it here itself. So we get u equal to v. Or we can write it as v is equal to u. If u equal to v is equal to u. That is, final velocity is equal to initial velocity. V stands for final velocity and u stands for initial velocity, isn't it? Final velocity is equal to initial velocity. This final velocity and initial velocity become similar in only two conditions. Which conditions? A choke is here, and now its velocity is 0. Its initial velocity is 0. After 5 minutes, it's again here. Its final velocity is also 0. What is the condition of choke? The choke is at rest, isn't it? Either the object is at rest or the choke is moving the 5 meter per second. After 10 minutes, it is again moving in the 5 meter per second. What is this motion called? Uniform motion, isn't it? Uniform motion. That is, we can tell that if no external force acts on a body, the body continues to be in the state of rest or uniform motion. That is Newton's first law, isn't it? So from second law, we comes F is equal to ma, F is equal to m into v minus u by t, that is substituting the value of a, and we open the bracket mv minus mu divided by t, take this t to the other side, it becomes ft equal to mv minus mu. And if no external force acts on the body, F into T equal to 0. 0 is equal to mv minus mu. Taking this mu to the other side, minus mu becomes plus mu equal to mv. Cutting those m, and what we get is u equal to v or v equal to u. Final velocity equal to initial velocity for only two conditions: if the body is at rest or if the body is following a uniform motion. So from second law, we reached at the first law, and hence you have to conclude, if no external force acts on the body continues to be in the state of rest or uniform motion. That is itself Newton's first law. Hence, we proved Newton's first law from Newton's second law. That is the answer. Hope this is clear, and you can expect it in 2 mark questions. Okay, thank you for watching, and we will be discussing more type of problems in our group, physics separate group, subject group. We will be discussing the type of problems, that is numerical problems based on the equation F is equal to ma and P is equal to mv, whose equation is P equal to ma, linear momentum is equal to mass into velocity, force equal to mass into acceleration. We will be discussing more problems based on this in the next classes or in our subject group according to the time. Okay, thank you for watching. Have a nice day.